In this chapter, we will be covering an introduction to simple experiments. This is the first chapter in the section on making causal claims. In this figure, we're looking at the effect of laptop and longhand note-taking on test performance. Researchers Paul Mueller and David Oppenheimer in their 2014 study conducted an experiment that compared the effectiveness of two methods of taking notes in class. 67 college students were recruited to come to a laboratory classroom, usually in pairs. The classroom was prepared in advance, where half of the time it contained laptops and the other half notebooks and pens. Having selected 5 different TED Talks on interesting topics, the researchers showed one of the lectures on a video screen. They told the students to take notes on the lectures using their assigned method. After the lecture, students spent 30 minutes doing a different activity meant to distract them from thinking about the lecture. Then they were tested on what they had learned from the TED Talk. The results Mueller and Oppenheimer obtained are shown in the figure. Students in both the laptop and the longhand groups scored about equally on the factual questions, but the longhand group scored higher on the conceptual questions. Figure 10.3 shows an example of measuring persistence. Figure 10.4 indicates the results of Leonard's and colleagues' study on persistence in babies. In example 2, Leonard and colleagues recruited more than 100 babies aged 13 to 18 months to participate and randomly assigned them to either an effort or a no-effort condition. In the effort condition, the babies watched a model try to get a toy frog out of a plastic box. The model repeated, "How do I get this out?" while trying several different ways. And after she succeeded, she said, "I got it out." Then the model tried several times to unhook a toy from a fastener, saying, "How do I get this off?" and "Yay!" after she succeeded. In the no-effort condition, the model worked with the same toys for the same amount of time, but simply took the toy frog out of the box 3 times in a row and easily took the toy off the fastener 3 times. After modeling each condition, the model handed the baby a toy that played music with a large white button that looked like it should start the music but actually did nothing. The researchers recorded how long the baby spent playing with the toy and how many times they tried pressing the button. As figure 10.4 depicts, the babies in the effort condition pressed the button about 11 more times than the babies in the no-effort condition. The researchers made a causal claim that seeing just 2 examples of an adult working hard to achieve her goals can lead infants to work harder at a novel task relative to infants who see an adult succeed effortlessly. Now, do you think the results of the study support the researchers' causal claim? In an experiment, at least one variable needs to be manipulated and one needs to be measured. These variables become classified as either independent or dependent variables. To make a comparison, half of the variables become manipulated as the experimental group and the other become the control group. Which one is manipulated and which one is measured? Note-taking method and number of anagrams solved correctly. For manipulated variables, the researcher assigns participants to a particular level of a variable. An example is note-taking method, where there are 2 levels, computer and longhand. The measured variable is the one that is recorded for what happened in terms of behavior of attitudes based on self-report, behavioral observation, or physiological measure. An example is the number of anagrams solved correctly. An independent variable is manipulated by the researcher. An example is note-taking method that was used in the academic achievement study. Independent variables have levels, and the levels of an independent variable are called conditions. So if your independent variable was note-taking method, the levels or conditions could be longhand or laptop. It's up to the researcher to select the levels or conditions. The dependent variable is the one that is measured, or the outcome. The dependent variable depends on the condition of the independent variable. A control variable is one that is held constant and does not change. This is to compare the group without change to the experimental group that is given a change. An example from the text is in the pasta study. All participants ate the same kind of pasta from the same type and size of plate. Let's talk about why experiments support causal claims. Remember, experiments establish covariance. Is the cause variable related to the effect variable? Experiments establish temporal precedence. Does the cause variable come before the effect variable? And well-designed experiments establish internal validity. Are there alternative explanations for the results? Let's talk about how experiments establish covariance. Both the baby study and the note-taking study show covariance between the independent variable and the dependent variable. Covariance is indicated by a difference in group means. In the pasta study, participants in the large bowl condition ate more calories than those in the medium bowl condition. Independent variables answer the question compared to what? You might recall that our personal experiences don't have the benefit of a comparison group. For example, let's say you think you always persist at building IKEA furniture at home, but you're not sure if it's because you watched your parents trying things over and over, or you don't have anything to compare it to. If independent variables don't vary, then covariance has not been established. Covariance is also about the outcome. Your outcome variable or your dependent variable is important too. If the number of buttons pressed was the same in both groups of the babies, then there is no covariance, and watching models interact with toys in different ways does not relate to the number of times the baby presses the button. Experiments establish temporal precedence. This means that the cause variable precedes the effect variable. In the baby study, the experimenters manipulated the independent variable, which was the modeled activity. They did this first, and then they measured the dependent variable second to ensure that the causal variable preceded the effect variable in time. Well-established experiments establish internal validity. As you will recall, it is of primary importance to interrogate internal validity when making a causal claim. You need to be able to rule out third variable explanations and feel confident that the independent variable caused the change in the dependent variable and not some other variable. Confounds are these alternative explanations, and they can threaten internal validity. For example, in the note-taking study, it would be a confound if the participants in the laptop group were given more difficult test questions than the students in the handwritten group. In this case, your independent variable, the note-taking methods, would be confounded with the test difficulty. So you couldn't be sure if it was the way the students took notes or the difficulty of the tests that affected participants' score. There is a design confound when a second variable varies systematically along the independent variable and provides an alternative explanation to the results. An example to consider is the study on note-taking. If all of the students in the laptop group had to answer more difficult essay questions than those in the longhand group, that would be a design confound. We would not know whether the difference in conceptual performance was caused by the question difficulty or the note-taking method. If a design confound is present, it threatens internal validity and we can't support a causal claim in that case. It's important to note that internal validity is only threatened if there's a systematic variability of the independent variable. For example, if those participants in the large dish group had higher quality pasta than those in the medium dish group, then that's systematic variability and a design confound. Unsystematic variability is random and affects both groups. It is not a confound. However, it can make it difficult to detect differences in your dependent variable. Let's talk about selection effects. A selection effect occurs in an experiment when the participants in one level of the independent variable are systematically different than the participants in the other level or levels of the independent variable. For example, Lova's 1987 conducted a study to test an intensive therapy for children with autism. Some children in the study received the new treatment, and others continued their usual treatment. However, they were not randomly assigned to these groups because some families lived too far away for the intensive treatment, and other families requested the intensive treatment. The researchers found that the autistic symptoms of children in the intensive treatment group showed more improvement than those in the usual treatment group. However, this study had a selection effect whereby the families in the intensive treatment group were probably systematically different than those in the usual treatment group. Therefore, it's important and impossible to determine the reason for the improvement because of the selection effect. Avoiding selection effect with random assignment is one way of assigning participants to levels of the independent variable such that each participant has an equal chance of being in each of the groups. There should be no systematic difference between groups with random assignment. Assignment doesn't always work well if your sample size is small, as groups may be imbalanced. Some researchers prefer to use matched groups with small samples. Matching involves matching groups of some variables, such as IQ. We randomly assign the 3 participants with the highest IQ to the 3 groups, then assign the next 3 highest participants, and so on. The match group ability allows you to avoid selection effects. There are many forms of experiments, and the most basic distinction is between independent group design and within group design. In an independent group design, there are different groups of participants placed at different levels of the independent variable. For example, each participant was randomly assigned to either the large or medium serving bowl condition. There are 2 types, pre-test only and pre-test post-test. Within group design requires that each participant is presented with all levels of the independent variable. An example would be in the note-taking study in which each participant engaged in both longhand and laptop note-taking methods. Post-test only design, also known as equivalent groups or post-test only design, is a type of independent groups experiment in which participants are randomly assigned to independent variable groups and are tested on the dependent variable just once. In a pre-test post-test design, or an equivalent group, participants are randomly assigned to at least 2 different groups and are tested on the key dependent variable twice, once before and once after exposure to the independent variable. An example is from a study on the effects of mindfulness training. In this study, 48 students were randomly assigned to participate in either a 2-week mindfulness class or a 2-week nutrition class. 1 week before starting their respective classes, all students completed a verbal reasoning section of the Graduate Record Examination, the GRE. 1 week after their classes ended, all students completed another verbal reasoning GRE test of the same difficulty. In the figure, we can see that while the nutrition group did not improve significantly from the pre-test to the post-test, the mindfulness group scored significantly higher at post-test than at pre-test. Deciding which design is better depends on the researcher's particular goal. In some situations, it is problematic to use a pre-test post-test design. For example, if the dependent variable involves eating or physical exercise, participants might become full or exhausted by having a pre-test and a post-test. In other situations, a pre-test post-test design makes sense. Post-test only designs can still be very powerful, given their combination of random assignment and a manipulated variable. But if you want to make sure that the groups are equivalent at the start, you'll need a pretest. There are two types of within-group designs: concurrent measures design and repeated measures design. Measures design is a type of within-group design in which participants are measured on the dependent variable more than once. Researchers Erica Boothby and her colleagues used a repeated measure design to investigate whether a shared experience would be intensified even when people do not interact with the other person. They recruited 23 college women to a laboratory. Each participant was joined by a female confederate. The two sat side by side, facing forward, and never spoke to each other. The participant was told that the two chocolates were different, but in fact they were exactly the same. After tasting each chocolate, participants rated how much they liked it. The results showed that people liked the chocolate more when the confederate was also tasting it. In current measures design, participants are exposed to all levels of the independent variable at roughly the same time and a single preference in the dependent variable. The example on the slide is about looking preference in infant research. Within group designs require fewer participants. For example, some people really like dark chocolate and others do not. But in a repeated measures design, people bring their same level of affection for chocolate to both conditions, so their individual liking for the chocolate stays the same. The only difference between the two conditions will be attributable to the independent variable, whether people were sharing the experience with the confederate or not. If they want 20 participants in each condition, they will need a total of 40 people for an independent groups design. However, if they run the same study as a within groups design, they will need only 20 participants because each participant will experience all levels of the independent variable. I'd like for you to think, do within group designs fulfill the three causal criteria? Does it have covariance? Is there a manipulated independent and comparison condition? Is there temporal precedence? That being that the independent variable occurs before the dependent variable? Is there internal validity? Have you questioned if there are third variable explanations? Order effects have the potential to threaten internal validity. An order effect occurs when exposure to one level of the independent variable influences reactions to other levels of the independent variable. Order effects are confounds for within-group designs because it might not be the levels of the independent variable that cause change in the dependent variable, but rather the order in which the conditions were experienced. One type of order effect is a practice effect, which occurs when participants either get better at a task from practice or get worse at a task due to fatigue. Another type of order effect is carryover effect. This occurs when there is contamination carrying over from one condition to the next. An example is when you brush your teeth and then drink orange juice. The unpleasant taste of the orange juice is a carryover effect of brushing your teeth. In order to avoid order effects, researchers use counterbalancing, which is presenting levels of the independent variable to participants in different orders. There are two types of counterbalancing, full and partial. Full counterbalancing occurs when all possible condition orders are presented. An example, with 2 conditions there are 2 orders. With 3 conditions there are 6 orders. The example in the figure illustrates full counterbalancing. Partial counterbalancing occurs when only some of the possible condition orders are used. An example, a researcher could present a randomized order for each participant or a Latin square in which each condition appears in each position at least once. There are 3 main disadvantages with within-group designs. First, repeated measure designs can have order effects, but those can be controlled for using counterbalancing. Within-group designs are sometimes not practical or possible. Suppose someone has devised a new way of teaching children how to ride a bike called Method A. She wants to compare Method A with the older method, Method B. Obviously, she cannot teach a group of children to ride a bike with Method A and then return them to baseline and teach them again with Method B. Once taught, the children are permanently changed. In such a case, a within-group design, with or without counterbalancing, would not make sense. The third disadvantage is demand characteristics, or experimental demand, which occurs when participants pick up on cues that lead them to guess the experiment's hypothesis. Should a pre-test, post-test independent groups design be considered a within-groups design because participants are tested twice, once at pre-test and once at post-test? It's important to remember that in a true within-group design, participants are exposed to all levels of the independent variable, and the levels can be counterbalanced. But in a pre-test, post-test design, participants experience only one level of the independent variable, not all levels. We'll now use Mueller and Oppenheimer's 2014 study on note-taking to illustrate how to interrogate an experimental design using the 4 big validities as a framework. To interrogate construct validity in the note-taking study, you would start by asking how well the researchers measured their dependent variables, that is, factual knowledge and conceptual knowledge. Mueller and Oppenheim 2014 provided examples of the factual and conceptual questions they use, so you could examine them and evaluate if they actually constitute good measures of factual learning and conceptual learning. These 2 examples seem to be appropriate types of questions because the first asks to directly recall a lecture's factual information, and the second requires people to understand the epiglottis and make an inference. To interrogate the construct validity of the independent variables, you would ask how well the researchers manipulated or operationalized them. In the Mueller and Oppenheimer study, this was straightforward. People were given either a pen or a laptop. This operationalization clearly manipulated the intended independent variable. A manipulation check is an extra dependent variable that the researchers can insert into an experiment to convince them that their experimental manipulation worked. A manipulation check was not necessary in the note-taking study because research assistants could simply observe participants to make sure they were actually using a laptop or pen in accordance to the assignment, the random assignment. A pilot study is a simple study using a separate group of participants that is completed either before or sometimes after conducting the study of primary interest. Researchers may use pilot study data to confirm the effectiveness of their manipulation before using them in a target study. Although manipulation checks and pilot studies aren't always needed, they are often used by careful researchers. Recall that Mueller and Oppenheimer 2014 originally proposed that laptop note-taking would let students more easily take notes verbatim compared to taking handwritten notes. In fact, their study included measures of verbatim overlap, so they could test their theory about why laptop note-takers might perform worse. After transcribing each person's notes, they measured how closely the notes overlapped verbatim with the video lecture narration. However, it turned out that people in the laptop condition had in fact written more verbatim notes than people in the longhand condition. In addition, the more people wrote verbatim notes, the worse they did on the essay test. The researchers supported their theory by measuring key constructs that their theory proposed. Generalizing to other people, we can ask, how were the participants selected for the experiment? Was random sampling used? In the Mueller and Oppenheimer 2014 study, the 67 students were a convenience sample rather than a random sample of undergraduate students from university at Princeton. Because they were a convenience sample, you can't be sure if the results would generalize to all Princeton University students, not to mention to college students in general. In addition, because the study was run only on college students, you can't assume the results would apply to middle school or high school students. You can also generalize to other situations. External validity also applies to the types of situations to which an experiment might generalize. The note-taking study used 5 videotaped TED Talk lectures. In their published article, Mueller and Oppenheimer 2014 reported 2 additional experiments, each of which used new video lectures. All 3 experiments found the same pattern, so you can infer that the effect of laptop note-taking does generalize to other TED Talks. However, you can't be sure from the study if laptop note-taking would generalize to a live lecture class. You also don't know if the effect of laptop note-taking would generalize to other kinds of college teaching, such as team-based learning or labs. What if external validity is poor? Remember that in an experiment, the validity that is emphasized most is the internal validity. In order to achieve experimental control, that is, internal validity, researchers sometimes conduct their studies in artificial laboratory environments that may not represent the real world. Many experiments sacrifice real-world representativeness in exchange for internal validity, testing their theory and teasing out the causal variable from potential confounds were the steps Mueller and Oppenheimer took. Like most experimenters, they took care of it first. In addition, running an experiment on a relatively homogeneous sample, such as college students, means that the unsystematic variability was less likely to obscure the effects of the independent variable. Replicating the study using several samples in a variety of contexts is a step saved for later. Is the difference statistically significant? Is the difference between means obtained in the experiment statistically significant? Are you reasonably sure that the results did not occur by chance? If your result isn't statistically significant, then you can't conclude that you have covariance. How large is the effect? Effect size can help determine covariance. Typically, the larger the effect, the stronger is the causal effect. In experiments, researchers can express effect size in 2 ways. The first is original units. The second is standardized effect. An example of original units in the Mueller and Oppenheimer study are the number of questions answered correctly. The second is to use a standardized effect size. When there are 2 groups, researchers often use an indicator of standardized effect size called D. This coefficient quantifies how far apart 2 groups are on the dependent variable. It indicates distance between group means and how much scores within groups overlap. A large D equals change in independent variable to the dependent variable, and a small d means that a lot of overlap is present in your groups. If you take a look at figure 10.21, which illustrates that the difference between means is exactly the same in the 2 graphs, the effect sizes are different because of the spread of the scores. Which way is better depends on what your goal is. Original units are good for estimating the real-world impact. Standardized effect sizes are good for effects based on different types of units. How precise is the estimate? A 95% confidence interval reflects precision. A small n with more variability will have a wider confidence interval because it is less precise. We can calculate confidence intervals for both the original units and d. The 95% confidence interval for Mueller and Oppenheimer study is shown in the figure 10.22. As you can see, the confidence interval suggests a wide range of possible true population differences, including 0 and negative differences, meaning it is possible, if unlikely, that laptops are actually more helpful than longhand notes. Replication. Replication is another important step in estimating the population effect, which is to conduct the study multiple times and find multiple estimates. For example, in Leonard's study on baby persistence, another 120 infants got exactly the same results in Young's 2017 study. Mueller and Oppenheimer's study was published alongside 2 others that were almost identical, and all 3 found similar effects. However, some other researchers have found smaller or no benefits of longhand notes against laptop notes. When studies are replicated, you can combine their estimates to get an even better estimate of the true population value. This is when we would use a meta-analysis. Remember that internal validity is the top priority when interrogating a causal claim. The first question: did the experimental design ensure that there were no design confounds, or did some other variable accidentally co-vary along with the intended independent variable? Mueller and Oppenheimer 2014 made sure people in both groups saw the same video lectures in the same room, and so on. The second question: if the experimenters used an independent group design, did they control for selection effect by using random assignment or matching? Random assignment controlled for selection effect was used in the note-taking study. Third question: if the experimenters used a within groups design, did they control for order effect by counterbalancing? Counterbalancing is not relevant in Mueller and Oppenheimer's design because it was an independent group design.